On our next few examples, we're going to be graphing equations in x and y by plotting points. As we continue through this chapter, we'll make the work here more efficient. But if we want to graph something such as y equals x plus 2, when we are asked to graph that, that means to plot all of the points onto an xy coordinate plane, such as this down below, that satisfy this rule. The y value is equal to the x value increased by 2. And so if you want to organize your work, what I kind of like to do, and you'll see us do this, is we're going to organize our xy ordered pairs in a chart. And I think I might pick out some values of x here. They choose, in this case, to let x be 0, to let x be -4, to let x be equal to 2, and then increase each of those by 2 to get the corresponding y value. So if x is 0, our equation above says, well, the y is going to be 0 plus 2. That is 2. That is how they get this xy ordered pair that's going to be plotted down below. Okay? When they let x be equal to -4, y is calculated by taking -4 plus 2. So the y would be -2. -4 plus 2 is -2. When x is 2, and again, they just kind of randomly selected this. You could pick out any values you want. But if you choose x to be 2, plug it into your rule or your equation, y will be 4 in that case. Then you'll get on your graph paper, plot those points, and you will know that when you plot those points, those are only 3 of the infinite number of ordered pairs that satisfy that equation. But you need to get enough points to be confident in what your equation is going to be. You might want to calculate several other ordered pairs by letting x be 1, or -1, or -2, or -3. Then we can be definitely confident that what we've got going on there is a line. So we're going to draw, in this case, the line that contains all of those points. We're going to categorize this type of situation as a linear equation later on. But for now, we don't know really what the graph of these, what these are going to be. They're not all lines. We don't know until we plot some ordered pairs that will satisfy our given equation. So if you're given the equation y equals 1 over x, let's draw this little t-chart, and that will help us organize our x, y ordered pairs. Now, the rule is to get the y value, you're going to take 1 over the x value. Or you're going to do, when you do 1 over something, that's the same thing as calculating the reciprocal. Okay? Now, one thing that we want to make sure is, because we have a fraction, x is not equal to 0. Okay? If you let x be equal to 0, y would be 1 over 0, and that is undefined. So there's not going to be a point anywhere that lies on our y-axis. Remember, points that lie on the y-axis have an x-coordinate of 0. Not going to happen. We're not going to have a y-intercept, is what we'd call it later on this graph. But I might want to do some numbers for x that are positives and negatives. For example, what if I let x be equal to 1 and 2, and maybe I want to let x be equal to 5? I don't know. And then let's let x be equal to some negatives. How about -1, -2, and this time I feel like doing like a -4. And then we're also, you'll see, going to need some more values here in just a second. All right, let me get that organized a little better. There we go. I'm going to put some more values down here. Now, when we go to see what y would be for each of these values, let me first of all say when x is 1, our equation's rule says y is equal to 1 over the x value. So when x is 1, y is equal to 1 over 1, which is 1. When x is equal to a 2, y is equal to 1/2. If you want to put a decimal form for that, 0.5, that's fine. Okay, we can plot fractions in decimals. If x is equal to a 5, my rule says y is equal to 1/5, 1/5, which is 0.2. Let's see what we've got so far. Let's jump over to our graph paper and let's plot the point 1, 1. 1 for x, 1 for y. When x is 2, y is at 1/2. I'm going to do the best I can to eyeball that there. When x is 5, 1, 2, 3, 4, 5, y is 1/5, or 0.2. I don't know what's going on in this graph yet. We need a lot more points. Let's see what happens when x is a -1. Y is 1/-1, which is -1. When x is a -2, I'm changing x to be a -2, y is -1/2, or -0.5 if you prefer the decimal equivalent. Let's see, when x was a -4, my rule above says y is equal to 1/-4, -1/4, or -0.25. I'm going to jump over to the graph paper and plot those points. -1 for x, -1 for y, right there. -1, -1. -2, -1/2 would be about right there. -4, -1/4, about right there. I still don't know what's going on, okay? Now, well, I do because I've seen this before, but you may not know what's going on. Now, I'm going to draw something and it's incorrect. What a lot of people want to do is say, well, it's going to do like this, and then it's going to come like this, and then it's going to do like that, and then, well, we don't really know, okay? That, I will tell you, is not it. You're going to need to, at times, pick out some more values so that it'll draw the picture for you, all right? So I think what I don't know what's happening is in my graph between -1 and +1. Remember, I can't let, I'm trying to X that out, okay? I can't let x be 0 because that's undefined. So I'm not going to be able to have a y-intercept here. But I do want to know, well, what happens for, like, when x is maybe 1/4 or 1/2? Or maybe 3/4. Let's try those. Going back to my equation above, if x is equal to 1/4, y is equal to 1/1/4, which is the reciprocal of 1/4, which is 4/1, or just 4. That's interesting, okay? What about when x is 1/2? What is 1/1/2? Well, it's 1/2's reciprocal, 2/1, or just 2. So, when x was equal to 3/4, my rule says y is equal to 1/3/4, which is 3/4 reciprocal, 4/3. So 4/3, you know, is the same thing as 1 1/3, 1.33333. Maybe that'll help us figure out what's going on for a little bit more of our graph. Now, y'all, when x is 1/4, I'm going to go over to 1/4, which is about right here for x, and then y is 4. So I'm going to go up 1, 2, 3, 4. That is 1/4, 4. When x is 1/2, that's about right here. When x is 1/2, y is 1, 2. There's 1/2, 2. When x is 3/4, I'm eyeballing that about right in here. 3/4, y is 1 1/3. That'd be about right there. So now I have a little bit better idea of what's going on. And what actually happens, and if you want to pick out some more ordered pairs, you can. What happens is you have like a little curve that does a little something like this. Okay? And then let's focus on what's going to be happening down there in quadrant 3. Let me edit just a little bit over here. When x is a negative 1/4, let's see what would happen if x is a negative 1/4. That's actually then just going to be the reciprocal of negative 1/4, which is a negative 4. And when x is a negative 1/2, y is the reciprocal of negative 1/2, which is a negative 2. So when x is a negative 3/4, y is its reciprocal, negative 4/3. Let's plot those points. Negative 1/4, negative 4, right there. Negative 1/2, negative 2 would live right there. Negative 3/4, negative 1 1/3, negative 4/3 would be about right there. So I get another little curvy looking shape down here in the third quadrant. I'm going to draw arrows on the ends of my graphs here to show that that would keep on extending in that direction that I'm pointing toward. That's one thing you do to graph. And then the last thing you do in graphing an equation is you label it with its formula. Y is equal to 1/x.